So page 24 deals with finding the value of c. It's indefinite integrals with initial conditions. So we're looking for, based off of the condition, the value of the c that would give us a particular solution rather than a general solution. Right? So we have f prime of c is equal to secant squared times 2x. So this is really the same as saying df dx is equal to secant squared 2x, which is really the same as saying df is equal to secant squared 2x dx. Integrate both sides. So we're looking at f is equal to the integral of secant squared 2x dx. Now, another way of thinking about U-substitution is, for me, I kind of think of it as the if only. All right, so if only this was secant squared of just an x. If only it was secant squared of x, I would know what to do. I'd be able to get tangent and be done with it. Tangent of x plus c. All right, but there's a 2x there. All right, so that's what I would call u. Whatever I would not want to have there, because that's the thing that causes it to deviate from the rule. All right, so du is equal to 2 dx, and this is a case of baby u sub because it's just deviating by a multiple that is constant. All right, so I could swap out the 2x for a u. I really just want to be able to get rid of the dx, so if I replace that with a 1/2 du, that'll accomplish the mission there. So I'm really looking for 1/2 secant squared u du, which is 1/2 tangent of u plus c. So that's what we're calling f. All right, but they gave us a condition, and that condition is that when x is pi over 2, f is 2. All right, so x is pi over 2. Well, I got a u, so I got to do a little substitution here. So f of pi over 2 is going to be 1/2 tangent of 2 times pi over 2 plus c. Now we know that that should give us a result of 2. 2 times pi over 2 is pi, tangent of pi is 0, so that's telling us that c is equal to 2. All right, so therefore we could say that f of x is really 1/2 tangent 2x plus 2. And that would be our particular solution. All right. Now there are some steps that you can kind of hop over once you realize that, oh, okay, this is just going to be f equals the antiderivative of negative 2x radical 8 minus x squared dx. Saves you a little bit of time. All right. So my u here should be 8 minus x squared. Du is going to be negative 2x dx. Which is tailor-made. That's precisely what I want, because I got a negative 2x dx here. So we're looking at the antiderivative of the square root, which I'm going to write as a power of 1/2 of u. 1/2 du, u to the 1/2 du, is going to be equal to f. Alright, so u to the 3/2, increase the exponent by 1, but divide by the new exponent gives you 2/3 plus the c. That's what f is going to be equal to. And they tell us f of 2 is 7. All right, but that's the x value of 2. So let's get an x in for u. 8 minus x squared. Find f of 2 based off of this function model. Knowing that that result ought to be 7. So 8 minus 2 squared, 8 minus 4 is 4. 4 to the 3 halves. I mean, you put this in the calculator, but 4 to the 3 halves. The root of 4 is 2. Cubed is 8. So times 8 plus c, 16 thirds. All right, 7 is really the same as 21 thirds. 21 minus 16 is going to be 5, so 5 thirds. So therefore, we're looking at f of x being equal to 2 thirds times 8 minus x squared to the 3 halves plus 5 thirds. Now this one is probably worth having a second look. You know, give it a quick double check. So I'm going to type in under y equals, I'm going to type in the function, or well, my general solution without the c. Eventually got it out. So 2 thirds 8 minus x squared, close it up, raise it to the 3 halves. All right, now I'm going to evaluate that for where x is equal to 2. All right, now that should give me 16 thirds. So we'll see. Alpha trace y1, 16 thirds. All right, then do 7 minus previous, oh, I hit the wrong thing. 7 minus the previous answer, second negative sign, 5 thirds, and there you go. All right, you could also go into the table, second graph, and go to the x value of 2, y value 16 thirds. You could also, since you know you're going to do 7 minus whatever you would get when you evaluate the function for 2, you could do 7 minus y1 of 2. All right, a bunch of different ways. All right. Numbers 13 and 14 back to trig functions. So antiderivative of tangent x dx. All right, we don't want to reinvent the wheel. All right, we talked about this in the previous page. The antiderivative of tangent x is the natural log of secant x. All right, if you want the proof for that, just go back to the previous page. Here it is. All right, ln of secant x. All right, so that's one video ago. Or you could do it with U-sub if you want, but if we already did it, you know, so why do it again? So f of 0 is equal to the natural log of the secant of 0 plus c, and this ought to give us a 3. So secant of 0, secant is 1 over cosine. Cosine of 0 is equal to 1. 1 over 1 is 1. Natural log of 1 is 0. So 0 plus c. 3 equals c. Therefore, f of x would be the natural log of the secant of x plus 3. All right, same idea for number 14. If you know the rule, even though it's U-substitution, I don't expect you to go through the motions for the sake of it. All right. So we know that this is the natural log of secant x plus tan x plus c, the proof for which is on the previous page also, right at the top here. Boom. So make use of that information. F of 0, natural log of the secant of 0 plus the tangent of 0 plus c. F of 0 ought to give us a 0, right? ln of, well, secant of 0, let's say, we just did that. That's equal to 1. Tangent of 0, right? Tangent sine over cosine. Sine of 0 is 0. Cosine of 0 is 1. 0 over 1 is 0. So this ultimately gives us natural log of 1, which is 0. 0 equals 0 plus c. So 0 equals c. And therefore f of x is equal to the natural log of the secant x plus the tangent of x. And there it is.